This is an example of what CSDL looks like. It's a language, but it's really simple. It's just conditions and logic. That's it. So here's a condition. The first part of it is a target. So this is which bit of information am I going to look in? The operator is how am I going to evaluate what's in there, and the argument is a value that you're looking for. So in this example, interaction.content, this particular target always has the message body of an interaction regardless of source. So it could have been a tweet, it could have been a Tumblr, it could have been somebody making a comment on a blog post. Doesn't matter what the source is, the content is always an interaction.content. And contains Starbucks is simply saying it just has to have that word in it. So it's a very simple example of how CSDL works. The colouring I've put in there, so the blue and the red and the green, when we type CSDL into the editor, it automatically colours it for you so that you know which bit's which and that you've got it right. Okay, so this first part about the targets, how do you know which targets that you're going to use? You know, I've explained what interaction.content is, but there are literally hundreds of targets. The best place to go and, well, there are several places to go and look. Let me give you a choice of places that you can go and look. So I'm just logged in on a trial account here. This is the dashboard. So if you don't have an account, just hit the login button on datasift.com and you can create a free trial account. And there's a link at the top for documentation. So here's the documentation site, and I'm going to click on Get Started. And if I scroll down the documentation, there's a section here for targets and augmentations. So I'm going to click on Targets, and that shows me a list of the targets, and then I'm going to click on Twitter as an example. That's a very common one. And it shows me a big list of all the possible targets in Twitter. Now, Twitter probably has the most number of targets. So I don't know about the most, maybe second or third most number of targets of all the sources. So for example, I could click on one of these. It's showing me the name of the target, what data type it is, which I'll come back to, and then a one-line description of what that target has in it. So I'm going to click on twitter.links, and it gives me a description of what twitter.links is used for, and some examples of how we could use that in CSDL. So the documentation is one place you can go to find more information. And it's really a case of just going through, looking at what they're called, checking what their descriptions are, and working out whether that's something that you want to use in your filter. A good place to go if you want some kind of ready-made CSDL and some ideas for what you might want to look for would be to look at the DataSift blogs. So if you go to datasift.com/blogs, there are some good examples in the blog posts. Next place to look, I'm going to go back to the platform itself. So in the web application, and I'm going to click on Data Sources at the top. Okay. And in Data Sources, it just lists out what all the possible data sources are, and you can activate and deactivate them here. I'm just going to scroll down, and I'm going to click on the Twitter data source. Clicking on the data source brings up a description of what this, in this case, social media source is about. It shows you a licensing cost on the top left for the number of interactions that are matched by your filter. But down towards the bottom, the bit I want to look at is target fields. So if I expand target fields, it just shows you what all the possible target names are in this particular source. So it doesn't give you a verbose description like the documentation does, but at least it lists them. So that's another place to look for target fields. So targets are an attribute of an input interaction which you can filter against. Okay, so it's some attribute of an interaction from one of the data sources you have enabled, and you can filter against a target. Some examples of targets. Interaction.content we've already looked at, so it's the normalized content of an interaction from any source. Just makes it really easy for you to do the analysis on. Interaction.mentions, again, it's normalized across all of the sources, but it has usernames, so where somebody has referenced someone else on that particular social media source, like in Twitter if you had @ followed by someone's screen name. Twitter.geo, this is quite a fun one to play with. It has geographic information for a particular tweet. So for example, if I tweet from my phone, it automatically includes where I am at that time. Whereas if I tweet from my laptop, I don't think it does. So there is a proportion of tweets which have geographic information included in that as a target in that interaction. So you can easily set up filters to look for people tweeting in a particular place. Links.domain, so links is an augmentation. Twitter is a proper source, of course. Links.domain is going to be the domain names of any links that are in the interaction. So if you have an interaction with maybe 3 or 4 links in it, even if they're shortened links, it follows any redirections that a shortener uses to the very end page, and it'll give you a list of all the domain names of the pages that are being linked to. Data types. Sometimes it's worth knowing what the data type is because it can affect the operator which you choose. So some of them are of type string. So for example, twitter.text or interaction.content is a string, so just a stream of alphanumerics. Strings are tokenized automatically. So that just means that we split the string up into words. The separator that's used between tokens is punctuation or white space. If you happen to be looking for something where you need to change how the tokenization works, you can do. For example, there was one support ticket I was looking at where someone was trying to match a brand name in another language where it had an apostrophe in it. Now usually the DataSift platform would take the apostrophe as being a separator between words. So what you can do is in the filter condition you can actually modify how the tokenization works so that you can look for things like brand names with apostrophes in. Integer is the next data type, so things like follower count in Twitter. If you want to know how many followers someone has who's just sent a tweet, that would be an integer, a whole number. You can have an array of integers, which is just a list of numbers. Floating point is a number with a decimal part to it. For example, follower ratio. Whenever we receive a tweet, we receive information of the ratio of followers to followees is of the person who sent the tweet, and that's usually a floating point number. Arrays of strings. So going back to the one I mentioned about the domain names of all the links that are in an interaction, the value of that particular target is going to be an array of strings, a list of strings. And then we have the geo ones. And geos just have longitudes and latitudes in. I'll show you an example of that one next. Okay, so operators is the next part. We've learned a little bit about different targets and where to go and find out more. So the operator is what kind of a comparison am I going to make? The first one we have is just exists. So that means if there is a value of any type in that target, then that condition is going to be true. So in this case, interaction.geo exists. Well, that's only going to be true if there is geo information in the interaction. So if that target has some value in it. Be very careful using exists. If you had something like interaction.content exists, that's going to be true for just about everything, and you're suddenly going to be getting hundreds and thousands of interactions getting sent to you, almost everything getting sent to you, which is a vast amount of data and will very quickly build up your licensing bill. String operators are very common ones. Example there is twitter.user.screenname, and then we've got 2 equal signs and DataSift. The 2 equal signs mean I want to see exactly this string and nothing else. So nothing in front of it, nothing after it, just that one word. And not equals is exclamation mark before an equal sign. Contains is a really common one too. Here we've got contains Hertz rental, and the table at the bottom is showing you that it's not sensitive to case. So Hertz rental with capital H and capital R is just the same as if it's all lowercase. If you want to be case sensitive, you can do. There's a modifier that you add in your filter. But the last example in the table is not going to match that one because it's not Hertz rental next to each other, which is what we have in the double quotes. Okay, so that's contains. Another really useful one is contains any. With contains any, you can have a comma-separated list of words that you're looking for, and if any one of those words is in your target, then you get a match. So if you're looking for hashtags or user IDs or lots of different things, contains any is a very common one. Sometimes you might be looking for some terms, perhaps a product name or a brand name, which is multiple words, and they're only meaningful if those words appear within a few words of each other. So if I wanted a Starbucks vanilla flan latte, for example, then I might be looking for those words only. I might look for Starbucks and latte only if they're within 4 words of each other. If I happen to have vanilla at one end of a 400-word interaction and latte at the other end, I don't really care. So this contains near, you can specify the number of words apart that these words must appear to get a match. Contains all. The contains any was like a logical or. So this or this or this or this. Contains all is like a logical and. It's saying I must have this and this. So you can have as many words as you like, comma separated, and you have to have all of them in the target in order to get a match. The operator in is for matching the whole contents of a target. So just like the double equals sign was matching a whole string. Well, language.tag is always going to return a single string with 2 characters in it, which is the language that that interaction was written in. But I've got 3 different languages that I want to match. So you would use the word in. So language.tag must be in, and then my 3 examples are here, en, de, and es. You could do the same with numbers. So if you have multiple numbers you want to match, where it's that number and nothing else around it, you'd use an in. Numeric operators are exactly like you might expect. So you could check if a number, if a target equals a number or doesn't equal a number, and then you have the usual greater than, less than, greater than or equal to, and less than or equal to. Sometimes this example we have here, something similar to this can be used for isolating spam accounts. So if you find a Twitter account where it's only been set up in the last couple of days, it's sent thousands of tweets, and it has almost no one who follows it, then that could potentially be a spam account. So these kind of comparisons of numbers are useful. Geo operators are great fun to create. If the interaction has geo information in it, and only probably about 5% of interactions do, then you can create a filter that says you must be within a certain area. Georadius, you specify a central point with a longitude and latitude, and then a radius from it. So in this case, 50 kilometers from the center of Istanbul. Geobox is you define 2 points with longitude and latitude again, and it assumes there's a rectangle between those points, and it's anywhere within that box. And polygon, you can have up to 32 points to make up a polygon shape. So the example on the slide there is a polygon around Heathrow Airport in London. The editor that we're going to look at makes it really easy to create these. You don't have to go and find out what the longitude and latitude of your shop that opened last week is. It just pops up a Google map, and you can click around in the Google map to create these shapes. Okay, so let me give you a quick demo next of the editor that we use to actually type this CSDL in and how to get it to work. So I'm just going to switch to my web browser now. First thing I'm going to do is I'm going to click on Data Sources, and I'm just going to check that I have activated some sources. So here we go. I've activated Twitter at the very least, and if I go to the next page, I've got a bunch of augmentations activated too. Okay, so at least I've got something coming into any filter that I'm going to write. So the next thing I'm going to do is up the top I'm going to click on Streams. Now I've got no streams configured at the moment on this account, so I'm going to click on Create Stream. First thing it wants is a name for my new stream, so I'm going to call it Starbucks. And then over on the right hand side I've got a choice of which editor that I'm going to use. So you might have already used Query Builder. So this is the graphical way of being able to navigate through all the targets from all the sources. But we're going to go for CSDL editor for this one and start editing. Now there are some things you can do in CSDL that are just so much easier than doing it in Query Builder. So for the more complicated your filter gets, the more likely you are to find it easier in CSDL. Now I'm going to start typing my CSDL in here. So I'm going to go for interaction.content. Now as soon as I've typed in that target, because it's a valid target name, it's turned it blue. So that tells me that that's valid. And I'm going to say contains all. Actually no, let's go for contains any. And I'm going to have Starbucks Dunkin'. Let's put that part in. Dunkin' Donuts would be a good one for the contains near. Perhaps I should do a demo with the contains near. So there we go. There's a valid bit of CSDL. So it's color-coded it all. There's a validate button here. I've hit validate and nothing has appeared at the bottom. Okay. If it didn't like it, if there was something wrong, it would show me an error message at the bottom of that editor. So I'll click Save and Close. And I can put a revision message in. Every time I hit Save and Close, it saves a new version of this filter. So at any time I can go back to an older version of it. So I'll put first try in there. Okay, this brings me to a summary screen for this particular filter. First thing you'll notice on the left is it shows me the DPUs for this particular filter. So these are the data processing units. This is related to the amount of computational power, processing power, the DataSift platform has to apply when it's running your filter. So a really complicated filter with lots of conditions in it is going to have a high DPU. Because mine is so simple, it's only 0.1 of a DPU, and that's actually rounded up. So if I were to run this, it's going to run at 1 DPU. The other part of the billing from the platform is the data licensing fee. So if my filter here for Starbucks and Dunkin' ends up coming back with 100,000 interactions an hour, which I doubt, but if it did, I would have to pay for those 100,000. But you can look on the data sources page in the web application here and it'll tell you what the current price is. So there's two parts to it. I could have a very complicated filter with a small number of interactions coming out, so I get a high DPU cost but a low data licensing cost. Or maybe I could have a pretty basic filter where the DPU is very low, but I get a lot of interactions coming out of it and my data licensing fee is going to be higher. The DPUs you can predict exactly because it says it here. The licensing is a bit more tricky. You're probably going to have to run your filter for a while and see how many interactions are coming out. And bear in mind, over a 24-hour period, that's going to change. And if some news event happens that relates to things that you're looking for, again, it could shoot up. So that's just the billing part of it. There's a live preview button here. So I'm going to hit live preview. And it just gives me a summary, a reminder of the data sources I have enabled. And I'm going to hit play at the bottom. Here we go. So there's Starbucks in those ones. Some tumblers coming in. Mostly they're tweets. Starbucks, Starbucks, Starbucks. Lots of them. Okay. Let me pause that there. We're not really going into analysing the interactions in this session, but just to quickly show you the icons you see at the bottom beneath the message. They're icons that relate to augmentations. So, for example, that funny looking K is the clout. So this is how influential the person is. So this Melissa has a clout of 49. The smiley face is because it's positive. We can do sentiment analysis on interactions to work out if they're broadly negative or positive, and you can put a value on it. And the EN obviously is that it's English in this case. So that's just a simple example. I'm going to click Edit Stream again. Simple example of creating a CSDL filter, compiling it, which is what the save and close does. So that compiles it on the platform within DataSift, and the preview just starts running it. If you were to actually want to use this filter, you would now be thinking about creating a recording task, perhaps, where you say, right, I'd like you to run this filter starting on this time and date, ending on this time and date, and this is the destination I want you to send the interactions to. Something like Amazon S3, Google BigQuery, MySQL, wherever you want to send it to. Possibly you want to run it against a historics archive. You only have access to historics if you have a subscription account. So if you're pay as you go, the historics button doesn't appear. But if you have a subscription, you have access to an archive of a lot of social media interactions. The biggest archive we have is the Twitter one. So that goes back for quite a long way, and you can run your filter against particular periods of time. So you might want to see what are people saying about your brand or your product or a particular person in December of last year, and then what are they saying about them in January of this year, and compare the trends between the two. So the same filter you write that runs against live data, you could apply that to the historic archive too. Let me go back to the next part of the CSDL. If I'm going to make my filter more complicated and better, then I'm going to have multiple conditions. If I have multiple conditions, I've got to tell it what kind of logic to use between them. So the first example there is very simple. I'm looking for twitter.txt having Starbucks in it, and the language has to be English. Slightly more complicated one at the bottom. It's got to be a tweet with Starbucks in it or a retweet with Starbucks in it. So it could be either, got an or, and either. Oh, sorry, no, and the language must be English and the confidence must be over 90% that it is English. Okay, so you can choose where you put the brackets, where you put the ands and the ors to get the effect you want with your filters. With this one here, you can negate particular conditions as well. So in this example, we want tweets that have Starbucks in, but not any that have the stock symbol of SBUX in. But we do want them to be in English. So as well as the and the or and the brackets, you can use a not to negate a particular condition. Back to my editor here, let me show you some other things the editor has. If I click this little black box here with the arrow in it, it shoots a toolbar across. And then there's a CSDL reference inside here. So if I click on the CSDL reference, it opens up a quick chooser. So I can go into here and I can quickly choose things, for example, clout and clout score. So it just makes it a bit easier than having to go back to the documentation to find the target. So I'll do an insert code. There we go. So you've got clout.score. Let's say it has to be greater than or equal to 40. And I'll click the little bar across again, and I want to go for a geo. So map location. Now this is where we can create polygons or radiuses for places that a tweet must have come from. Oh, I've accidentally put something in them. Let me reset the map. I've put a pointer in the wrong place. Where am I going for? San Francisco. There we go. Okay, so let's go to there. To there, let's go down to there. Let's do that. So there we go. Created a polygon around the downtown San Francisco area. Ooh. Maybe the piers as well. There we go. So I've just created this this polygon. I do insert map. It's automatically put in. Ooh, let's put it at the top here. So it's got let me go back to the start, interaction.geo and then geopolygon, and it's put in the longitudes and latitudes for the places that I'm looking for. Let me just go and put this clout score back on the next line. There we go. So being able to do the geo stuff is really easy. Now this should run okay and give us some hits, I think. Let me try a save and close. I won't bother with a revision message this time, and do a preview. And play. So I would imagine, this being San Francisco, there's going to be a lot of tweeting going on, and probably from a lot of smartphones. Okay, here we go. So we've got people here tweeting in San Francisco, and these are all people who have a clout score over 40. So we've got someone with a clout of 67 here, saying something happy about bacon, fat fried, sweet potato fries. Okay, there we go. So that's an example of multiple filter conditions in CSDL and using a geo. Do bear in mind, geo is great fun, but only about 5% of interactions have geo information in. If you do want to try and narrow your filters down to particular places, look at other targets like the user bio information. So for example, for Twitter, when you create your bio, your user details in Twitter, it gets you to put in your country, it gets you to put your time zone in. And various other social media sources have very similar things. So you could be looking for interaction.geo is within this area, or maybe Twitter.country is in a particular list of countries that you're looking for, or maybe you're looking for something in their bio that has a state name or a city name in it. So there are lots of other ways to go and look for that too. I think there's a worked example of that on one of the DataSift blogs, if you look at the blog site. Back to the slides here, just to finish off. So little hints and tips. For mentions, we have there's a target called Twitter.mentions, which has a normalized array of screen names which have been mentioned. So if somebody put @Beyonce in their tweet, then it's just Beyonce in the Twitter mentions target. Hashtags, you could look in the actual text of an interaction itself for the hash followed by the word, or there is a target called interaction.hashtags. Again, it's normalized across all of the different sources, and you don't have the hash in the front of it. The last one we have here is just a bit of a gotcha. Be careful if you're putting big comma separated lists of words and terms in, and then you edit them. We did have somebody who made a mistake and they left it looking like I have on this example here, where it's comma space comma. And it actually started looking for any interaction that had a space in it, which is most of them. And so very quickly you're going to burn through your data processing units and your licensing credit, and your storage wherever you're sending this to is going to get swamped with billions of interactions. So just watch out for mistakes like that, and also be careful when you're using the exists operator to use it with caution.